Hi guys, welcome back. Today we're going to be looking at, for this lesson, we're going to look at how to solve quadratics using factoring. So we're going to start from where we left off. We're going to solve some using a graph once again. So we're going to use graphing calculator, which means we are going over to Desmos to graph these three guys and see what their features look like. And then we'll do a quick sketch of them, summarize what the possible solutions could do, and then we'll look at how the graphing techniques that we've been looking at, the factoring techniques, that we've been looking at actually apply to stuff like looking at a quadratic equation. Okay, so let's start in Desmos. We'll graph this first guy here, x plus 3 multiplied by x minus 1. Notice it's in brackets, so each of those binomial factors, because there's two terms in each of those factors, and we will graph that exactly as it appears. So flipping over to Desmos here, this in here, I'm going to go over to Desmos, and let's just get rid of last lesson stuff. There it is. Okay, so again, we're going to do y equals, open a bracket, and we've got x plus 3, close that bracket, open a new one, x minus 1. On the keyboard, obviously, a little easier. If you're on a mobile device, you'll have to use the keypad for all the brackets and the equals and the squareds. And oh, no squareds in this one, so you're in luck. Okay, there's our graph. Wonderful. So again, here's the key features that we need to know. The x-intercepts. The y-intercept's helpful for graphing. Rarely is it asked for in just looking for a solution, but there it is. And there's the vertex. So filling in the chart that we just got. Let's get our chart up here. Where'd it go? There it is. There's our chart. Our x-intercepts are, for some reason, I'm doing a weird thing. Let's make it dance. There it is. Our x-intercepts are -3, 0, and 1, 0. There it is on the chart. Yay, like it appeared like magic. Woo woo. And then our vertex is -1, -4. So let's write that in. -1, -4. The axis of symmetry, we don't even need to look at the graph for this. It's x equals whatever the x coordinate of the vertex is. So it's x equals -1. And the max or min value, well, it helps to know if it is a max or min. We can see from the left to the right, it's going down, 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 hits that bottom, goes back up again. So it's a min of the y coordinate of the x-intercept, which is right here, -4. So we're going to write min of y equals -4. And we'll do a quick graph of it. So I'm just going to graph these key features. So -1, -4, -1, -1, 2, 3, 4. And I'm going to do these x-intercepts. So 1, 0, and -1, 2, 3, 0. Is that right? So look here, it's 1, 2 away. Yeah, and this is 1, 2 away. The x-intercepts from the vertex, that's how it should be. And then we can actually see one more point from the graph, 0, -3. So let's use that, 0, -3. And we can reflect that 1 away from the axis of symmetry, 1 more away from the axis of symmetry, gives us some more points to work with. And now we can just sketch our curve nice and smooth as we can, right through all those points, right to the edge, put an arrow on the end to show that it keeps going. I've done better graphs in my time, but it works. Okay, there's one. That's a little crooked, the arm on the left there. Whatever. Now let's do the second one. So there's our equation, y equals -2x, open a bracket, x plus 5, close a bracket. So y equals -2x, open bracket, x plus 5. There it is. It's beautiful. So let's zoom out a little so we can see the whole thing. There we go. And so there are its x-intercepts, -5, 0, and 0, 0. So I put that in that first box right there. Its vertex is right up here at -2.5, 12.5, -2.5, and 12.5. So notice how it was opening down. There's a negative in the front there. That's why it's actually opening down, that negative guy right there. So the axis of symmetry, remember, it's the x-coordinate of the vertex, so it's x equals negative 2.5. It's a line, a vertical line. That's why I have to say x equals, because it's stating the equation of that line. That is the axis of symmetry, or symmetry even. And is it a max or a min? Well, looking at the graph going from left to right, we can actually see it's going up, 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 hits that top value and goes back down again, never to return. So it is a max of y equals 12.5. Hooray! And then we just graph all these points. So how many boxes do we have here? 1, 2, 3, 4, 5, 6, 7. So it's 7. So I can get up to 14 if I go by twos. So let's do that. Each box is worth 2, 4, 6, and so on. But horizontally, I'll just go by ones still. So 1, 2, 3. Okay, label my axes, which I should have done on my previous graph also, and label the graph 2, y equals x plus 3, x minus 1. There we go, and I'll graph all those key points. So the x-intercepts of -1, -2, -3, -4, -5, 0, and 0, 0 are my x-intercepts. My vertex is at -2, 1, 2.5, and 12.5, which will be hard to do, but this is 2, 4, 6, 8, 10, 12. So halfway would be 13, so like a quarter point right there. That's weird, right in the middle of that box. It's strange, but it works. And now I'm just going to graph this. Again, this is just a quick sketch, so I'm not really spending too much time on the accuracy of it. There it goes. And again, I'd label this y equals negative 2x, x plus 5. Okay. And then the last one we're going to do is x plus 5 all squared. So let's do that here. X plus 5, close the bracket, then use the exponent squared. Notice that binomial's in the bracket. Outside the bracket, we're squaring it. And there it is. We have the x-intercept is the vertex, and there's only one x-intercept. So the x-intercept is -5, 0. That's because it's a perfect square. That's why that's happening. The vertex is at, well, -5, 0. The axis of symmetry is still x equals -5, and it's a min of y equals 0. So there it is, a -1, -2, -3, -4, -5, 0. And I'm just going to use the step pattern to make my graph shape look nicer. 1, 2, 3, 1, 2, 3, 4, 5 is up there somewhere. 1, 2, 3, and then up here somewhere. So there's my graph. It's perfectly beautiful. And I'm going to label it, and y equals x plus 5 squared. There it is. So we have a couple scenarios we could actually get where when solving a quadratic equation, we could get two real roots, and that's the first two examples. So you notice how we're passing through x twice in this one and twice in that one. So that's when the vertex is below x and it opens up, we cross through x twice. So it looks something like this. I'm just drawing it on that. That's a horrible graph. Or it could look like this, where the vertex is above x-axis and it's opening downwards, and it doesn't have to be on the right or the left of the y-axis. That actually doesn't matter, but just notice it's crossing twice. In both of these two scenarios, I've plotted on the one little axis. You'd only get one of those, obviously. Two real and equal roots. Well, that's like this third example here, where the vertex is on the x-axis, so it just sits on top of it, opening up or opening down. It doesn't matter. That's what it would look like, one of the two. And finally, no real roots. Well, that would be when the vertex is above x and it opens up. See, it doesn't cross the x-axis. Or when the vertex is below x and it opens down. And there you go. So we're going to look at factoring, how it can be used to find these solutions in the next video.